is an F1 car. Well, a very small version of an F1 car. But you may have heard of Formula One. Formula One is the pinnacle of motorsports. It's where cars regularly go over 200 miles per hour, which is pretty fast. But these cars must also take really high-speed corners. But how do engineers make sure that these cars don't slip and slide around track? Well, that's where something called downforce comes in. Downforce is the vertical component of the aerodynamic forces that act on an F1 car. Today, we're going to be talking about how the rear wing specifically contributes to the downforce of the car. Here, we can see an example of some air flowing at the rear wing. Air flowing under the wing gets more compressed than the air flowing over due to the curvature of the wing. This means the air flows faster, and as Bernoulli's principle states, this means the pressure must be lower. Here we can see a demonstration of Bernoulli's principle as I blow air across the top of the paper. You would expect that the paper to go downwards, but it in fact goes upwards. What I just showed you is exactly how an airplane's wings work. Basically, air flows faster over the top, so there's less pressure and less force on the top of the wing than under the wing, which pushes the airplane upwards. An F1 car is exactly the opposite. Air flows faster under, so there's less pressure and less force here, which pushes the car downwards. But hold on, why? Since the air is moving faster, fewer particles are hitting the wing in the same amount of area. This is because the particles are in a more concerted direction. This means a decrease in force, and since pressure equals force over area, pressure decreases. On the top of the wing, air is moving slower, which means a greater force and thus a greater pressure. This causes there to be a net downward force, which pushes the car into the ground, producing more friction by increasing the normal force. The normal force is the perpendicular contact force, and in this case is the contact between the car and the ground. And since friction is equal to mu Fn, where mu is the coefficient of friction and Fn is the normal force, if the Fn force increases, so must friction because they're proportional. In addition, Newton's third law states that when one object exerts a force on another object, that second object must exert a force that's equal but opposite on the first. So since the wing exerts a force on the air by deflecting it upward, the air must exert a force on the wing. This pushes the car into the ground. And hey, now you know about the physics behind a rear wing. And maybe you want to tune into the next F1 race.